Significant amount of solving that involves a word problem, but I'll guide you through it as always. Okay. You just have to pay attention, follow along, take down the notes. You know, the usual. Okay. Applying the laws of sine and cosine to word problems. Now that we've learned how to solve for sides, angles using sine or cosine law, we can start solving word problems. In general, you should include the following as part of your solution. So it's just, students like to know sort of what is expected or what are some common steps that I can take to be successful. And in general, if you follow this, you should be fine. Okay. Um, you draw a labeled diagram, of course. Put letters to it. If I ever ask you to solve the distance between a person and the hydro pole, give it a letter, right? Like I'm solving for X, I'm solving for Y. Put it on the diagram. If it seems you're stuck, right? I don't really know how to solve that thing. Then start solving for sides. Just start solving for things that you know how to solve for, right? And then kind of move into where you want to go. I've seen students doing some crazy stuff, like they run out of room on my test because they went like the long way, but they eventually get there. Who cares, right? You got there. Show how you set up and how you solve for missing dimensions. Round your final answers to do decimal places, including angles. Remember to check if your answer is reasonable. So remember I told you the longest side should be across the largest angle, stuff like that. Do my angles add up to 180, right? Maybe they don't. Right? It's like, oops, I need to check, right? Something went wrong. From time to time, I do make mistakes, as you know, right? So it could be that the question was done wrong, but most of the time, it's going to work out just fine, okay? Because I use a software that kind of calculates everything. It solves the whole triangle for me, and I just like cover up things that I don't want you to know, right? So that's basically how I make questions. Definitions, terms, concepts. Angle of elevation, angle of depression, those are very important, guys. So here's my best artistic, not very talented when it comes to that. Can do a lot of things, but drawing is not one of them. So anyways, what you always need to know is that when you're talking elevation or depression, there's always a horizontal line at play, guys. And that's the one I'm going to draw. I'm going to make a dashed line. So I'm going to take my, in this case, the eye level of this person. Okay. This is the horizontal. It's very important to always have a horizontal. The horizontal could be the ground. It could be the ocean floor, like the ocean floor. It could be just the surface of a body of water. It could be an invisible line. Like when you're flying a plane and you're flying up there, there's like technically your trajectory is the horizontal line, right? And so when you're looking up, let's say this person, there's something up, in this case in the sky, and there's something crawling on the ground here. I'm just going to make that a bug, right? So there would be definitely a line looking up, and there would be a line looking down, okay? And the angle that is formed, that arc that is formed between the horizontal, that's called the angle of elevation. And then the angle going down here is the angle of depression. Okay, so I know you've heard of it. If you haven't heard of it, then you were either not paying attention or it was just missed by whatever reason, right? Maybe, right, on whatever happened online in the last 2 years, like who knows, right? Who knows what all happened there. Sometimes you were logged in and pretended to be there, right, quote unquote, and but you went off and played your video games, right? Who knows? I'm just saying that's not you guys. It could be somebody else. Um, Supplementary angles, okay? It's angles whose sum is 180. So this comes back, everything comes back, even alternate interior angles and all that fun stuff that we learned in geometry comes with us here as well. It's all connected, guys. So this is where supplementary angles are going to be very, very helpful. If you, for example, you draw your scenario, you follow the story, you come up with various sides and whatnot, and all of a sudden you end up with one of these where the angle that you're given is outside the triangle. Okay, you should know, it should scream at you saying, hey, there's two supplementary angles there. You can easily get the angle that you really want, which is 150, sorry. Right, they add up to 180. So that's very important there that you catch that. Hey, right, that's those are supplementary angles. This could be the ground, and so it's a very easy way to get an angle inside the triangle you want. I'm going to give you a quick example where this is going to come up. Okay, you like stories? Okay, so you look. There's a tree here. Okay. So there's a point where you look up, right? And this is your horizontal again. And the story tells you that the angle of elevation is 30 degrees, right? Then either you or your friend, or maybe you keep walking closer to the tree to have a better look at that eagle's nest, right? And then you're told, hey, now your angle of elevation is 50 degrees. Because obviously the closer you go to an object, the higher up you're going to have to look, right? I think that makes sense to you. And so you're like, okay, I kind of see two triangles here, but I really want to work with this one here. Right? I want to work with that one. So at first glance, the 50 is outside the triangle, but you should quickly realize, no problem. If this is 50, I know this is 130, because these two are right next to each other. They are supplementary. Right? And all of a sudden, you have more information than you initially started with. So that's an example of where this is going to come in handy, right? Right, you start, right, you end here, and you kind of complete the story. We could find the height of the tree, guys. We could find anything you want, everything we've learned. You just transfer that skill over to this particular word problem, right? How close were you at the beginning, right? How close were you from the beginning to the tree, right? The base of the tree. We can find all of that out, but that comes later. Right now, let's just continue with our terminology here. You know what a guy wire is? It comes up, so hydropole, you know your hydropoles, right? And I know you know what a guy wire is. As soon as I draw this, you know when they have these supports with a yellow sleeve sometimes around it, so you don't cut your head off when you walk, or when snowmobilers like buzz by it, right? So they in the streets, sometimes guy wire. So this is the wire right here, okay? This is the guy wire. So it's to support any post, antenna, you name it. Sometimes there's many, right? And so that's what we call a guy wire. So obviously you can see that there's a triangle formed. And it looks like a right triangle. Sometimes you will have right triangles, so that's kind of neat, but we can still use sine law, cosine law for that. And sometimes you'll have stories where, let's say you have your flagpole, right? And there's a guy wire this way, and there's one going the other way, right? And obviously the flagpole, unless it tells you that it's leaning, right? We are assuming that it's a 90, right? So, right, this stretch here, they could ask you, hey, how far how far from the base of the flagpole is the first wire attached? So this could be wire 1, this could be wire 2. It works actually quite nice when I tell you what you can expect, so students are a bit more prepared for that, right? So this would be X, this would be Y. How far from the base of the pole is the second wire attached? Hey, we couldn't call that Y, right? What's the length of wire 1? What's the length of wire 2? We can find all of that and more, right? We can find the height. How high up the pole are these wires attached, right? That's all going to come our way. Same, it's like nothing new, no new trig. It's the same trig we've been using. It's just now it's a word problem, right? And that's what's actually so valuable about this course. If you ask me, just being able to solve for x is not the same as solving a word problem, right? That's what in the real world, that's what you're going to encounter. You're going to encounter problems and you're going to have to solve it, right? So here is the first word problem of this unit. From scratch, I should say. I had a word problem, but I gave you a diagram. And so I'm going to try to get this in 15 minutes, less than that, okay? A radio antenna is supported by 2 wires on opposite sides. The wires are anchored 60 meters apart. The wires themselves are 60 meters apart, okay? One wire has an angle of elevation of 62 degrees. I'm going to start highlighting important information. The other one has an angle of elevation of 75 degrees, and they're 60 meters apart. Okay, I think I know where this is going, right? I think you should have a pretty good idea of what the diagram is going to look like. By the way, if I assign a question that has to do with compass directions, north, 50 degrees west, or anything like that, skip it for now. Don't do it. Okay? I'll dedicate a lesson to those. Right now, just focus on everything else. So, hey, let's sketch it, okay? So we've got, I'm just going to imagine the wires are 60 meters apart, right? So from here to here, they're anchored to the ground. I know that's 60 meters. And then I find that it's common sense, but you would have to see the fact that they both have different angles of elevation. That tells you that the wires are not the same length, okay? I hope that you realize that. And so I kind of will make it 75. So I'm going to make it like this. A little off-centered. And the antenna is going to be right here. This is my antenna here that it's transmitting, okay? It's not necessarily the whole height of the triangle because these wires are attached to it to support it, right? So this is the point where the 2 lines meet. So I'm going to go ahead and put 62 here. To be honest, if you flip this on me, I would be fine. Like I wouldn't take any marks off so long you have that in there. Determine the length of each wire. I'm going to call this wire sub 1. I'm going to call this wire sub 2. That goes as well. You can call it X and Y if you want. In this case, I'm going to stick with that. And make sure that you indicate that the 60 goes from end to end. It's not just this, it's end to end. It's safe to assume, because we weren't told otherwise, that there's a 90-degree form between the ground and the antenna, right? Most of the time, antennas are straight, right? Unless something is off, right? So let's go ahead and find the lengths of each wire. So I actually left this. I always like to talk about some assumptions that are made that are not necessarily stated. The ground is flat. Obviously, we're Manitoba, Mr. Dirksen, right? But right, it could be that it's not. It could be that it's all bumpy and hilly or whatever. So we're making an assumption that triangle is not symmetric. Is not symmetric, right? It has different base angles there. And we're also assuming wires are connected at the same height. Okay, these are the assumptions we're making here when we're solving this thing. You don't need to state them, okay? Like I just wanted to make an observation about that. So let's go ahead and solve, okay? I will give the angles letters A, B, C, because the question isn't going to do that, right? When you graph your own, it's not going to be given. So I'm going to give it letters. And what law would I have to use to solve this one? What do you think? Anybody? Sine law? Did you say cosine or sine law? I'm not sure. We know that if it's sine law, we have a pair, right? Let's try to find a pair. Can we find a pair? Keep in mind, this is going to throw you off. That line is like, I wish I could erase it for a bit and then redraw it, but just think of it, the whole triangle without that. Okay, so this angle right here can be is paired up with the 60. We've got two angles, so we really know the third angle B there. Okay, this is a hidden pair. So I will go B. I'm going to first say that this is a hidden pair. Okay, angle B is 180 minus 62 minus 75. Let's solve that first. Angle B is 43 degrees. Okay, so 43, I'm going to write that in here. Forget about the antenna for now. Just think of the big triangle, right? You now have a pair, correct? Okay, now have a pair. Sine law, sorry. Think of cosine law. The only one you can solve using cosine law is if you know all three sides, or if you have side, angle, side, meaning, right, you've got two sides with the angle sandwiched in between. You don't have any of that here, right? So you kind of said, you know what, I think this is a sine law scenario. So I solve for that, now I have a pair. So let's go ahead and solve for, you choose, I'm going to go wire 1. That's my first step here. So I'm going to use that pair I just created. 60, right, is equal to. If I want to find wire 1, I need to use which angle? 62 or 75? I need to use 75 to find that side across from it. That's right. And so that's going to be wire 1. Wire 1 is 60 times sine of 75 divided by sine of 43. Wire 1. Just going to have to trust me on this one. It's 77.68. And we have meters. We are dealing with meters, so that's what our answer is going to be. Wire 2, so you know what, I like to clean it up a bit if I can. So you know, like this is my wire 1 work right there. Then I'm going to say, hey, this is wire 2, and I'm going to box that in once I'm done. Okay, so same thing, same pair. I'm not going to deviate from that pair. Okay, and in this case, I'm going to use angle 62, this one, which is paired up with W2, right, that side. And so it's basically copy paste, except for that sine of 62 step, right? That's the only thing that has changed. So W2, and we're expecting we're expecting it to be, I need to make a correction and a confession. I got this one wrong here. I mixed up the sides. This one is 8498. Did anybody catch that? My bad. And you know how I caught it? I caught it because I was gonna put down 8498 here, and then I realized, wait a minute, that's a smaller angle. It can't be. That's when I caught it. So I just labeled W1 and W2 the other way on my key here. So this is 7768, okay? That's what I mean by make sure your answer is reasonable, okay? And so wire 2 is right here. It's all in one place. I can go get it. We're done now with B. So B is done. So section C, find the height of, it says calculate how far up the pole the wires are attached, right? So how high up the pole. It's asking to find the height of this triangle, not the antenna, because we don't know how far up the antenna, but how high up the pole, we can figure that up. Okay, so find height of triangle ABC. And do you remember how to do that? That is the question. And one way would be to go W1, right? In this case, you know both of these sides. You can go W1 times sine of 62. That will do it. Sine of angle A in this case. Right? So it's 8498 times sine of 62. And I will actually make sure I get this right. What happened there? 75.03 meters. And because we have some time, I want to do one more that you will encounter. I want to add it to this question, makes it easier. We don't need to redraw. If you wouldn't mind, it could have also been found by going W2 times sine of C. Okay, same thing. So here, D. How far from the base of the antenna is wire 1 attached, anchored, sorry. To the ground, that is. So how far from the base of the antennas is wire 1 anchored? And I will grab a highlighter for that one to show you what I mean, right? How far from the base is wire 1 anchored? And that after we do this, that's it for today. I'll just give you some questions to try, and then we're done. So let me just go up to the diagram. And so what it's asking is this right here. It's asking what this is. It's not 60, right? We know 60 is from end to end. It's just asking that. So you're dealing with that right triangle, correct? You need to cut it. You need to deal with this little triangle. So let's do that in our, just down here. It just has to be a sketch, right? what do we know about it for sure that has not changed? This is 62 there. We just found that this is 75.03. We know that W1, right, is 84.98. And should we call this, I'm going to call this X. That's what I'm after. Please don't say, you have to realize that this top here is not 43, correct? It's not 43. Like I had labeled the top 43, but you're just taking that right, you're taking this off here, cutting it, so that is not 43. But I do know how to find it, correct? Let's call this angle X, big X, like that. I know 2 out of the 3 angles here, so angle X is 180 minus 90 minus 62. That's 28, right? 28 degrees. So I just found that that's 28 here, which is the angle I need to find X. Okay, so this is 28. We're almost done. Do I have a pair? Yep. Sine of 90 is across that side. So sine of 90 over 84.98 is equal to sine of 28 over X. And then you just go ahead and multiply that. Do you remember what sine of 90 is? It's 1. Yep. And I just made this one up, so I actually have to calculate this. That's 39.89.5, which rounds to 90. 39.90 meters. Could you figure out the other one now? The other side? Yeah, it's 60 all across. Just subtract that from 60, or you can, if you really like to do more work, you just cut the other one and do the exact same thing again, and they should add up. Right? Okay, you see the homework is right at the bottom of this, and this one, they're actually fairly simple. I must say, you're going to get harder ones down the road. I will just show you real quick what I mean by that. Page 12 in this workbook, it has a bunch of questions, and the answer key is right in there, right next to it. Just flip through the answer key, and you'll have it all. Okay? See you tomorrow, guys. Thank you very much. Hang in there.